Beginning this class, we would be discussing on the concept of inequality. We would discuss the concepts, and also we would be discussing the various problem-solving techniques of inequality in mathematics. Now, the first question that comes to one's mind is, what is inequality? Going by the meaning of the term inequality, is very simple. When something is not equal, but how is it reflected in mathematics? Let me first explain that through some examples, okay? When you talk about inequality in mathematics, there are basically two types of inequality or problems of inequality that we encounter. The first one is based on functions, okay? I'll explain. So, throughout your junior classes, you have handled various functions and equality of the same with zero. Maybe you haven't identified what you are doing. You are actually equating certain functions to zero to solve them out, to find out the various points within the function where the function becomes zero. Let me give an example. Let's say the linear equation x minus 5 is equal to 0. You had solved this in class 6 or maybe class 5 or class 4. What were you doing at that point of time? You have a function, let's say x minus 5. And when you find out x minus 5 equal to 0, you were basically finding out the point on this function where x minus 5 equals to 0. It was very easy to solve. Of course, such easy equations got more complicated as you became more mature, when you started solving more problems. But maybe at that point of time, you hadn't realized you were actually solving a function. You were actually equating a function to 0. Why just a linear equation? In class 9, you had solved quadratic equation. Let's say something like this. X square minus 4x plus 4. Let's say this is the function. When you equated it to 0, you had solved a quadratic equation. You know that this particular equation has two equal roots, 2, 2. What you did? You equated this function to 0 to find out at what values of x the function becomes equal to 0. You are essentially finding out the roots of the equation. Even in inequalities, this term root has a very important significance. Roots, you'd be continuing to finding out roots even in inequalities. I'll come back to that a little bit later on. But when we say inequality, what we essentially do is we find out the points on x when the function is not equal to something. So the first equation, let's say x minus 5. If you convert it to x minus 5 less than 0, if you make this an equation, this is not an equation, this is an inequation. You are trying to find out the inequality of the function to 0, basically less than 0. It can also be greater than 0 as well, whichever way you try to find out. Can you observe that root of this linear equation has a significance in it? Why just the linear equation? It can even be the quadratic equation, x square minus 4x plus 4 greater than 0. You are trying to find out the points when this particular quadratic equation is greater than 0. One small question, if you are inquisitive about it. Can this function ever be less than 0? Think about it. Maybe I'm jumping the gun a little bit, but let me continue to explain, okay? So the first type of inequalities that we have is, we have certain functions and we try to find out the points where the function is not equal to 0, okay? It may be less than, it may be greater than, and such functions can be algebraic functions, especially polynomials. The simple ones you have already seen. Polynomials where it's a linear equation, maybe x minus 5 less than 0. That's an inequality. Or x square minus 4x plus 4 greater than 0. That's an inequality. It can be higher order polynomials as well. Not just polynomials, it can be any algebraic function. Let's say we have an equation like x square minus 5x plus 6 divided by x square minus x plus 1. And you are asked to find out when is this greater than 0. You have to find out the points, the values of x for which this function becomes greater than 0. But the function is this term, x square minus 5x plus 6 by x square minus x plus 1. Okay? Not only just algebraic functions, you can have trigonometric functions. Example, you may be asked to find out when is sin x plus cos x greater than 0. That's an inequality on trigonometric functions, okay? It can be logarithmic functions and so on. So basically, any type of function, and we try to find out the points of the independent variable where it is not equal to 0. That's an inequality. And this type of inequality is very common. Now, I have given this inequality in just one variable. There is just one variable, right? X. A complicated problem may have two variables. It may also have three variables. But of course, at your level, it would be mostly on single variable, inequality on single variable, okay? And this inequality problems can be extended into a number of other concepts of mathematics. Example, you may be asked to find out the domain of a function, the range of a function, and those problems. So domain range of a function, those problems are actually an extension of inequality. So you need to have a good grasp of inequality of this type to find out the domain and range of a function. Having said that, this type of inequalities are actually very easy to solve if you know the right techniques, okay? So there are some techniques which are used to solve this kind of inequalities, mostly the algebraic ones. Now, we would not be discussing the inequalities on trigonometry in this series of videos. We would be discussing that in the trigonometry classes. But as of now, we would be focusing on the algebraic inequalities, okay? That will be coming in the next video. In this video, we are just giving you the concept, trying to explain you what are inequalities, okay? Next, I hope you have understood the first type of inequality, which is on functions. The next type of inequality is certain generalized statements, okay? So this type of inequality is not confined to variables or finding out the value of the variables where the function is not equal to something. These are more generalized ones. Let me give you an example, okay? Let's say I have two numbers, A and B, and I say that A plus B is greater than or equal to root over of AB. This is always true for any value of A and B. And this is a generalized inequality. This is a very simple one, actually. And you can easily find this out from A minus B whole square greater than equal to 0. You know that a minus b whole square is a positive number, which is always greater than 0. But this second type of inequality, the generalized statement ones, can be really complex. Some of the inequalities are really complex, and you need to understand the behavior of numbers quite well. Of course, there are some starting points like this, a minus b whole square greater than equal to 0. You need to know the various types, the various starting points which help us in getting to the end result of inequalities. So one is this, a minus b whole square greater than equal to 0. There is something called arithmetic mean greater than equal to geometric mean greater than equal to harmonic mean. This is also a very powerful tool, the number 2, to finding out or to proving to some inequalities, okay? There are other techniques as well. But having said that, I admit that the second type of inequalities are much harder to solve compared to the first type of inequalities. But in multiple choice questions, you don't get the second type of inequalities much, okay? But they're good to solve, good to understand number systems. This second type of inequalities are more common in Olympiads. The RMO, the NMO, this second type of inequalities are very common. But the first type of inequalities, where you solve certain functions, these are essential for the multiple choice type questions, okay? Yeah, you can also say that there is a third type of inequality which tries to find out zones in a plot or in a coordinate system. It tries to find out the zones where a certain rule is followed. Example, x plus y less than 2. This is the x-axis, this is the y-axis, and you are trying to find out the zone within this plot where x plus y is less than 2. This is actually an extension of the first type, and it's also quite easy to solve. Now, what I would do is, beginning the next class, I would start discussing on the first type of inequalities. I would show you certain techniques to solve these problems. There is one important technique which actually helps you in solving most of the algebraic kind of inequalities. But I would not directly get into the technique. I would first give you the background, the concept which helps you in solving these problems. Actually, that particular technique is derived from the concept that I would be explaining you in the next video, okay? So I hope you have understood the different type of inequalities in this class. Let's jump into the next class, where I would be discussing on the first type. I would explain the concept of inequality for a function based on certain plots, based on certain key points, okay? Especially this term root. Thank you.